Okay, let's start this question. So the first step would be log 2 to the power minus 1 and 3 to the power minus 1. Then there is log 4 to the power minus 1 and 5 to the power minus 1. Same for the another one, log 8 to the power minus 1 and the base 7 to the power minus 1. Now we know this fundamental that the powers will be taken outside from the inputs and from the base. So when you take the power outside, that is minus 1 and minus 1, they will get cancelled out. So you are just left with log 2 base 3. Similarly, log 4 base 5 and log 8 base 7. I hope this step is clear. Now, there is a fundamental in the log properties that is 1 upon log to the log a base b equals to log b base a. So I can say the next step would be log 3 base 2 plus log 5 base 4 log 7 base 8. So I have used this identity here. Now, log 3 base 2 plus log 5, I can write my base 4 as 2 square, and similarly log 7 base 8 as 2 cube. The concept here is the powers can be taken outside. So I can say it is log 3 base 2 because the power is 1, it is same log 5 base 2 and the power of 2 can be computed like half because 2 is in the denominator. Similarly, the 3 is in the denominator. In the next term, it can be taken like this. So these powers can be transferred back to the inputs. The input is 5 and the input is 7. These are some fundamentals of log. The identity used here is log a base b, log a power b equals to b log a with the base k on both sides. Okay, the power can be taken outside the log from the input. So I can say it is 5 to the power half with the base 2 and log 7 base to the power log 7 to the power of 1/3 with the base 2. Now, next identity here is I can multiply all our inputs. These are some fundamentals of log, and it is a very advanced question of log. So I hope that these fundamentals are clear to you. I am just solving it. So the identity used here is log ABC base k equals to log a base k plus log b base k plus log c base k. So it is just a identity used here. So I can say it is log root 45. Is it clear or not? Because I can write my 3 as 9 square. And when I multiply 3 with 5 to the power half, it would be root 45. So I am at this stage. Okay, so there are two observations here at this stage. I can say that this value is less than log root 64 times 8 to the power 1/3 with the base 2. There is an inequality that I have to use here because the options are in this format. So this is 8, and that is 8 to the power 1/3. That is 8 to the power 4/3. And what is the cube root of 8? That is 2. So it is 2 to the power 4, and that is just 4. So x is less than 4. The identity here used is log a with the base a equals to 1, because you can see when the power 4 is taken outside, this power 4 is taken outside, I will be left with log 2 base 2, and that would be 1. Second way is I can say that double of the question can be written like this. Now I am just shifting back the coefficient 2 to the input, and it will be 45. I hope it is clear. The square root will be removed. And what is the second power of 7? That is 49. So this inequality is greater than log 45 times 27 to the power 1/3 with the base 2. I have to use another inequality here. So this can be rewritten like this, 3, and this is 135. And I can say this 135 is greater than 128. Why I'm using these type of values, because I have to make a value according to the base. So it is 2 to the power 7, and 7 can be taken outside. So I can say x is greater than 3.5. So finally, I can say that x is less than 4 and greater than 3.5. I hope it is clear. Thank you.